Alright, so let's take a look and see how we actually approach each of these. So for the adding and subtracting problems both, we're going to need to have a common denominator in order to do the addition or subtraction. Now our current denominators are 8 and 2 for both of these. You have a couple different options of what you can use. I saw a lot of people who use a common denominator of 16. That works. However, it's a little bit more work than you're going to have to do. Because what's a smaller denominator that we can make them both? 8, yeah. And so I'm going to go with the smallest one I see. And so I'm going to make both of these fractions over 8. When you're getting your common denominator, notice how I started by writing it? I just wrote 2 fractions over 8. Then I worry about how I get there. Now the 3/8, of course, that's already over 8, so that's going to stay at 3/8. For the second one, I need to turn the 2 into an 8. Now what do I multiply 2 by to make it into an 8? 2 times 4. And so whatever I multiply the bottom by, I multiply the top by the same thing. And so that's why that one becomes 4/8. Once you have your common denominator, then you can go ahead and add straight across the top. So 3 plus 4, that's going to give us a 7. And we need a common denominator because it stays the same. A nice general rule in math and algebra and all the stuff we do, if two things have to be the same, it's going to be because they're going to stay the same. All right, the subtraction, of course, now is going to work very similarly. We need a common denominator at the start. And yes, you could use 8. You could also use 16. Either way, the only difference is that if you use 16, you got to do a little reducing at the end. So I go with the same common denominator. The fact that subtraction changed nothing there. The only difference here is we do the subtraction. Now when we do that subtraction here, of course, the denominator stays the same, but then we do 3 minus 4. What is 3 minus 4? -1, yeah. So we end up getting a negative in our fraction here. Now, technically speaking, you could leave your answer looking just like this, a -1 all over 8. But it tends not to look quite as nice or clean. And so what I'd have you do then is when you have a negative in either the top or the bottom, not both, because if it's both, they'll cancel each other out. If you have a negative in the top or the bottom like this, that means the whole fraction is negative. So I'm going to write the negative in front of the fraction rather than just in the top or in the bottom. It means the same thing, but it's a little bit cleaner. All right, now on to our multiplication. So to multiply fractions, this is like the one fraction operation that, like, before you ever learn anything about fractions, works the way you think it probably should have. We're just going to multiply straight across the top, and we're going to multiply straight across the bottom. So 3 times 1, that gives me 3. 8 times 2 on the bottom, that gives me 16. Does 3/16 reduce at all? No, so that one's done. That's all you got to do for that multiplication. Now the division, eventually it'll be that simple, but we got to do one step first. When doing division, we always flip the second fraction. It's always the second, regardless of which one's bigger or smaller. It's always the second fraction. And when we flip it, we change it to a multiplication problem. So your next line looks like this. Sometimes I'll see somebody who will flip it on one line and then change it to multiplication on the next line. It actually has to be a single step. Both things happen at the same time. Change it to multiplication and do the flipping. All right, now we can go ahead and multiply straight across the top, straight across the bottom. So 3 times 2 on top, 8 times 1 on the bottom. We got 6/8. Does that reduce? Yes, it does. What can we divide both 6 and 8 by?
3/4.
2. And so when we do that, that ends up giving us a 3/4. So our final answer here is 3/4. Now these 4 problems are bringing us back to stuff we've done before. You know, it's certainly practice and review. And technically what we're going into is practice and review too, just it's this part that gets a little bit rusty. Because we want to take a look and see what happens when we have a fraction with a whole number. So go ahead and write down these 4 problems, then we'll walk through them together. All right, so then let's start taking a look through these. The 6 plus a half, there's 2 different ways you can approach it. I'm going to show you both, and then you can decide which one you like the most. The first method is that we turn the 6 into a fraction, we get a common denominator, we do the addition, then we simplify from there. So just to show you really quick what that would look like, and I'm showing it to you really quick because I'm betting you're going to like my second method a little bit more. So 6 as a fraction is 6/1. And then I'm going to add that to 1/2. Now I need a common denominator, so I'm going to make that a 2. So that's going to be 12 over 2 plus 1/2, which gives me 13/2. Now 13/2, that's kind of an ugly look, so I might turn that into a mixed number here at the end. How many times does 2 go into 13? It goes in 6 times. With how many left over? 1 left over. So that ends up equaling 6.5. And yet, an answer of 6.5, can you see how we could have gotten there maybe a little bit quicker? 6 plus 1/2 is 6.5. That's the other method. Because since it's just a whole number plus a very simple fraction, it's a fraction that's less than 1, when we do the addition, it just gives us 6.5. And so we really could have gone straight there. You don't have to go through all of that extra work to come up with 6.5 in this case. Now you can, but I don't really want to. I don't imagine you want to either. So when you see that kind of a setup, that's an easier way to approach it. So let's take a look at the 6 minus 1/2. It's not 6.5, but we can actually reason through it the same way. Because if I start with 6 and I take away 1/2, it's not going to be a 6 anymore. What's the whole number part going to be? It's got to be a 5, right? Because I've only gone down less than 1. So it's got to be 5 and something. So if I start with a whole and take away 1/2, how much is left? 1/2, right? So it's 5.5. And that's our final answer. And again, you could do this the long way as well. You could turn it into 12/2 minus 1/2, which gives you 11/2. And then how many times does 2 go into 11? It goes in 5 times with 1/2 left over. That works. But I'm wanting to give you some tools that you can use to be able to do these without relying on doing as much on paper. Because if we build up a few of these instincts, then day-to-day life, when these things come up, you're going to be able to handle them easier. All right, next up, 6 times 1/2. Again, a couple ways you can think about it. The formal mathematical way. Let's make sure you have that down. Because while you don't need it on this problem, there are some where you might end up actually needing to use the formal mathematical way. So if I'm going to do 6 times 1/2, I'm again going to turn the 6 into a fraction. Anytime you have a whole number and you want to turn it into a fraction, you write it over 1. So 6 becomes 6 over 1. So I have 6 over 1 times 1/2. Now I multiply straight across the top and straight across the bottom, which gives me 6 over 2. What is 6 divided by 2? 3. And so 6 divided by 2 gives me 3, so that's my final answer. That's the formal mathematics that's going on behind it. Now, the other way, the shorter way that we could look at this and know, we're doing 6 times 1/2. That means we're finding out what is half of 6. And half of 6, of course, is 3. All right, the last one. This is the one that often will get people a little bit stumped here. We're dividing by 1/2. The answer is not 3. But that's what our instincts try to tell us at first when we see this. Because 6 divided by 2 is 3. And half of 6 is 3. But when we divide by the half instead of dividing by 2, it changes things up. So again, I'll show you the formal mathematical way here. I again turn my 6 into a fraction, so 6 over 1 divided by 1/2. And then remember how we divide by a fraction. We flip the second and multiply, yep. And so it becomes 6 over 1 times 2 over 1. And so if we do that multiplication, 6 times 2 on the top gives me 12, and 1 times 1 on the bottom is 1. 12 over 1 equals 12. So notice what it really did. When we divided by 1/2, it was the same as multiplying by 2. And so by remembering that rule of we flip the second fraction and multiply, you can see something like divide by 1/2 and instantly say, oh wait, divide by 1/2 is the same as multiply by 2. Because I know I multiply by the fraction after it's been flipped. And so it lets us get some of these values a lot quicker. Right, now to practice that idea a little bit, I got 4 more problems for you to do. So please go through and do each of these four, write them down, then do all of them you can. If you get stumped on one, well, let's skip it, go do the next problem. We'll go through them here together in a few moments. All right, so let's actually start taking a look through these now. So the first one is 1/2 plus 6. What is 1/2 plus 6 going to give us? That one gives us 6.5, yeah. Because when we add, does the order in which we add matter? No. Addition, it doesn't matter. So for instance, 2 plus 3 gives us the same thing as 3 plus 2. So 1/2 plus 6 is the same as 6 plus 1/2. So it gives us 6.5 just like the last one did. Now in the second problem, we're doing 1/2 minus 6. When we subtract, does order matter? Yes, it does. But the nice part is that with subtraction, even though the order matters, the only thing it changes when we flip the order is the sign. What was 6 minus 1/2 again? That was 5.5. And so if I do 1/2 minus 6, it's negative 5.5. So when we change the order of subtraction, the only thing that changes is the sign on the answer. And again, you could have figured this out if you weren't sure by doing it the long way. You turn the 6 into 12 halves. 1 minus 12 on the top gives me a negative 11 over 2. And then we can turn that into the mixed number of the negative 5.5. All right, 1/2 times 6. I switch the order. Does the order matter in multiplication? Nope, it doesn't change anything. So 1/2 of 6 is still 3. And then 1/2 divided by 6. Does order matter with division? Yes, it does. Now, it's not going to be as simple as just changing the sign, though. So let's actually work this through and see what it does change. Then we'll actually be able to see what the general impact is. So I'm going to work it through here. So I do 1/2 divided by, turn it into a fraction, 6 over 1. And then I do the division by flipping and multiplying. And now I can go ahead and multiply. So if I multiply across the top, 1 times 1 is 1. 2 times 6 on the bottom gives me 12. So it gives me an answer of 1/12. Notice how this compared to the 6 divided by 1/2 that we found earlier. It's the same number in there, but it's now on the bottom of the fraction. Basically, if you switch the order of division, you're flipping your answer upside down. So for instance, if our answer was 2/3, when we changed the order of division, it would have been 3/2. And it's all because of, notice that what changed is which one we flipped. And so rather than flipping the 1/2, the 1/6 flipped. And that's why our whole answer is flipped then. Because like the whole thing was upside down.